Let's start this problem. A force and a couple are applied to a beam. You can see that there's a couple here. The couple that 150 pound and 150 pound, and you can see that opposite in direction. This is a couple. This couple will produce a moment like this. This will push like this, and this will push up. The same magnitude, opposite in direction. There's a distance between them, a perpendicular distance. So this couple will move the beam like this, counterclockwise. Okay? He said a force and a couple. A force 200 pounds. This is the force 200 pounds, and the couple. The couple mean they are together. Couple together. 150, 150. This is the couple, and this is the force. Applied to the beam. This is the beam. See the beam? This is the beam. Replace the system with a single force applied to a point G and determine the distance D. So he wants to know G and D. So the equivalent force or a single force is going to be at this point. Of course, we have only one force, 200 pounds, and we have a couple. Now, how could we do this? Let's look at this. So we're going to redistribute this everything like this. We have 6 feet, we have 4.5 feet, we have 7.5 feet, 6 feet. And we have the couple, and we have the force, 200 pounds. Now, let's find the moment of the couple. So the moment of the couple is, you should find the distance between this couple. If you know this is 6 feet, and this is 6 feet, that's 12. What's the total? Total is 6 plus 7, 13, 13.5, 14, 18. So all 18 and minus 12, that's 6. So between these two couples are 6 feet. So we can do 150 times 6. So we'll do it like this. 150 times 6. And that's equal to what? 900 pound feet. And it is going, as we said here, it's clockwise. Clockwise. So the answer would be 150, 150, opposite directions, and the perpendicular distance 6 feet. So it's clockwise. And the answer is 900 pound feet. You multiply 150 times 6. Okay. So now we're going to do the beam like this. We have a force, 200 pound at point C. Remember the force? It was at point C. Okay? And we have the couple moment. And we just found it. Now we need to find the equivalent force at point G, a distance D from A. Okay? We know that this is 4.5 feet from the example. But we don't know the distance between this equivalent force and the 200 pounds. So we're going to make this one X. So now, remember the moment at D, it was clockwise. So it's a negative. So we're going to do minus moment. And 200, so this is going to do what? If you do it the moment at this point, at point D, so 200, and it's going to be positive, but 200 with the distance from G, it is 200 times X, equal to 0. So if you take moment at this point equal to 0, you have to account for this moment that's clockwise, which is negative minus M, plus 200 times the distance X. So we could find X. So the moment is minus 900, X is equal 4.5. So we find 4.5. So what's D? D is 4.5 plus 4.5, that's 9. So D, the distance is 9 feet, and the force is 200 pound down. Okay? So the force is 200 pound down, and that is the force that we should put it at G, and the distance is 9 feet. Now, the second part of the question, it said, solve part A, assuming that the directions of the two 150 pound force are reversed. So reverse is like this: 150 up, 150 down, and 6 feet. So remember the other one? The other one was 50 down, 150 up. So this is gonna be, it's gonna rotate like this with the force, clockwise. When you reverse them, which means that they're gonna go counterclockwise. That's positive. It's gonna be the same magnitude, 150 times 6. So it's gonna be 900 feet. That's the answer. But it's gonna be counterclockwise because it's gonna go like this. Look at this force and look at this force. So this is gonna push like this. Counterclockwise. So now let's solve the rest. So the moment we know it, 200 pounds we know it, and now we know 4.5, and we know x, and we know 200 pounds, and we know d. Now let's find x. Let's take moment at point G, which is the moment. This is going to be positive moment. 200 times x equal to 0. What was x here? X would be equal minus 4.5. If this is minus 4.5 and this is 4.5, what's d? 0. So if you reverse, the force gonna be where? Here at this point, not at G. So the force is at a distance d0 and force is 200 pounds down. Okay, thank you.